I'll teach you a new lesson. I hope that lesson is there in the wall of your classroom. I'm going to teach about classification of elements. Okay, just periodic classification of elements. Okay, so what subject is it? Chemistry. Wonderful, very good. You know what do you mean by elements, right? What do you mean by elements? Elements. One. I don't know your name, so some of you please stand and tell me what do you mean by elements. You tell me, boy. You are telling very loudly. What is elements? Wonderful, Sid. Elements are substances, okay? They are made up of same kind of atoms. Substances that are made of same kind of atoms. Can you give me some examples? Wonderful, wonderful, wonderful. Super, wonderful enough. Okay, so these are all elements. Okay, and there are nearly 118 elements discovered so far in this world. How many? 118, more or less 118 elements. Okay, so how are we going to learn about all these 118 elements? Should we learn about all these 118 elements first of all? Yes. Why? Why should we learn about these 118 elements? Only if we know about these 118 elements, we can utilize those elements to make our life easier. Why do we use hydrogen? You listed some elements, right? Hydrogen, lithium, boron, beryllium, you listed so many elements. Every element has got different properties. Do you agree with that? Every element has got its own properties, and every elements are used for different purposes. Every element is useful and they are used for different purposes. So, in order to identify which element is used for what purposes, only if we know that how to utilize that element, we can utilize that element to the optimum level, isn't it? Only if we understand what is the value of gold. Gold is an element, right? Only if we understand what is the value of gold, we will handle it properly, isn't it? If we don't know, if we do not have any idea about gold, imagine how would we handle gold? We will not take care of our studs. We will just like that put it somewhere and go. We don't know how to use it. We don't know whether we should use it for ornamental purposes or we can use it for doors and windows. We doesn't know how to think, how to use this gold, if we doesn't know how to use this nickel, chromium, if we doesn't know how to use carbon, which is all mixture of elements which is used to make alloys, stainless steel. Many of these steel which you see is stainless steel. Stainless steel is an alloy which is a mixture of some elements, right? Only if we know the uses of these elements, we can use that elements in the correct purpose. If we doesn't know the uses of these elements, we will not handle it properly in our life. Am I correct? So we should learn about all the 118 elements to use it in the proper way in our life. So that is why how to learn about the properties of all the 118 elements. Is it easy? Is it easy to list the properties of all the 118 elements at once? If your teacher is asked to tell about their class students, she can easily tell. If she is asked to tell about the characters of whole class students, how will they list? They have to separate it. These are the levels of 7th grade. These are 8th grade, 9th grade. They are capable of doing this. 7th grade is capable of doing this. 6th grade students, they cannot do all such heavy works. 6th grade students can do some sort of different works. Only if we know the capability of your level, we can use those, we can use you people to the optimum level, right? That is why only when we know, when we have a good understanding of these elements, we can use these elements to the good level. Understood? So why should we learn about all the 118 elements? To use it to the optimum level to make our life easier. Okay. So how are we going to do that? We can't put every element in one place and we cannot learn about it. It is very tough and difficult. Okay. So in order to learn about these 118 elements, we require a classification. Okay. Like how you are classified into different groups. Okay. Even in this class, we can divide you into different groups. Like what are your bus number, based on your bus number, based on your houses. You would have houses in your school, right? Like yellow house, green house, likewise. So we can classify you and then we can give you any sort of activities. We can use you people to the optimum level. Likewise, only when we classify these elements in a proper order, in an organized pattern, we will be able to learn about these elements very easily. Okay. So you understand why we require classification of elements? Why? Only if we classify these elements, we can study about these elements easily. Okay. So you understand two things now. We need elements. We have to study about all the elements. Only then we can use it to the optimum level. And second thing, what you understood now? We need classification of elements to study about those 118 elements. Do you agree with these 2 points now? You are all clear. We have to learn about the elements and that is why we need classification of elements. Okay. So now, scientists, long ago, so long ago, very long ago, okay, scientists started working on it, working on dividing the elements into different groups. Okay. So first, Greek scholars, Greek people, they started classifying these elements. They, in the very primitive period, in very olden age, they classify these elements into 4 different elements, like as we call it as Panchabhutangal in Tamil. Okay, they divided it into 4 elements like water, air, earth, and fire. Okay, these were the 4 bases of classifications. They categorized all the elements into. But this classification didn't help very much to study about the properties of every different elements. Okay. So then later, after some time, this kind of classification didn't help the people. So then again, there came another individual scientist who is called as Lavoisier. Have you heard about this name? Where did you hear? Very good. And do you know who is the father of chemistry? My spelling could be wrong. Anton Lavoisier is the father of chemistry. Okay. Why do we call him as the father of chemistry? Because he discovered so many, his contribution to chemistry was very much more than compared to other scientists, and he is the scientist who discovered oxygen. Okay, you know what are the uses of oxygen? Without oxygen, there is no combustion. There is no life. Very good. There is no life. We need oxygen, without which we cannot respire. And combustion is a very essential process, without which, without oxygen, combustion cannot take place. So oxygen is essential, and he discovered oxygen. Who? Anton Lavoisier. Okay. This scientist, he attempted to classify the elements based on the valency of elements. Okay. You people know what do you mean by valency of elements? Have you learnt it? Yes. Wonderful. The combining capacity of the elements. The number of electrons the atom is losing or accepting from other element is valency. Okay. Based on the valency, Lavoisier tried to classify the elements, who are all monovalent elements, who are all bivalent, who are all trivalent, who are all polyvalent. So he classified the elements based on the valency. Okay. But later, even this classification didn't work well. Okay. Didn't help us very well, because there were so many elements in monovalency. Okay. Sodium is a monovalent element. Chlorine is also a monovalent element. But sodium is a electropositive element and chlorine is a electronegative element. Okay. So though these 2 elements are monovalent, but they have entirely different properties. So this classification also did not help us to learn about the properties of these elements. Okay, so this classification didn't help us much. So then later came another scientist who is called as Dauberiner. Okay, who is he? Dauberiner. This scientist did his classification in which is called as triad. His classification is named as triad. What do you mean by tri? Three. Okay, tricolor flag, triad 3. So in his classification, he made his table with 3 columns and 3 rows. Okay, that is why his classification is called as Dauberiner's triad. Okay, he had 3 columns and 3 rows. And he divided the elements based on the atomic mass of those elements. Based on the atomic mass. Do you people know what is atomic mass? The mass of more or less, okay, the definition is not exact, but more or less, which contributes to the mass of the atom. He classified it like this, okay. Sodium, potassium, calcium, strontium, barium, chlorine, bromine, and iron. Okay. So he classified it like this. In his table, there is a significant character which says the average of the atomic masses of the first and the last element in the column will give you the atomic mass of the middle element. I'll repeat it again, listen carefully. The average of atomic mass of the first and the last element in the column, okay, will give you the atomic mass of the middle element in the column. This is how his classification is. So when you calculate the average atomic mass of these 2 elements, sodium and bromine, you will get the atomic mass of strontium. Okay, when you calculate the average of atomic mass of potassium and iodine, you will get the atomic mass of barium. Okay, this is how he classified. And when he prepared this classification, there were nearly some 36 number of, roughly some 36 number of elements were discovered in his period. So he prepared n number of triads, okay, so many triads which could come under this condition. It should give the atomic mass of the first and the last element. So he divided these elements in these triads. He started preparing more triads which should follow this rule. Okay, so later when scientists started discovering more elements, after 36 elements, when scientists started discovering more elements, they have to prepare so many triads, which is again a tough job, okay, which did not help scientists to learn about the properties of different elements. That study also didn't help us well. Okay, so this classification also failed out. And then came another scientist, okay, who is called as Octaves Newland. The scientist's name is Newland, okay, and he prepared a table which is called as Law of Octaves. Law of Octaves. You might have heard this number, right? What is this octave? Brilliant students, okay, 8. So his table, Newland's table, from the number itself, you can identify that the columns will have 8 columns, okay. And since he is interested in music, okay, in our classic music, we would have how many musical notes? 7. We call it as Saptaswarangal, right? Saptaswarangal, sa, ri, ga, ma, pa, da, ni, okay. Likewise, in Western music, they would have 8 notes, okay, which will be like sa, ri, ma, fa, lo, ti. It goes like this, okay. There will be 8 musical notes in Western music. When he tried to classify these elements, the first thing he did is he arranged all the elements based on the atomic mass. like how Dobereiner did. Okay, like how Dobereiner did, he arranged all the elements based on the atomic mass. Start telling the rhyme. Hydrogen, helium, lithium, beryllium, boron, carbon. Enough. We'll go like this. Okay. So he listed all the elements like this, and then he found there is a similarity between the first element and the eighth element. Okay, and then he found the same similarity between the second element and that eighth element. Okay, helium. Okay, hydrogen. Okay, goes like that. Okay, so he found similarity between every 8 elements. His table is called as law of octaves. So he put his classification because of this character. Okay, he found a similarity between every 8. First element, properties of first element is more or less similar to the 8th element. The property of second element is very much similar to the 9th element, 8th element to that element, the property of third element again to the 8th element. Then he divided these elements based on this similarity and he arranged it in a same column. Okay, law of octaves.
Totally, how many elements present in this periodic table?
118. 118. 18.
All these 180 elements, all these IUPAC is published?
No, sir. Still, there were few elements which the IUPAC name is to be under research.
Actually, already 2018, November 16 is already all these 118 elements IUPAC name is published.
Oh.
Okay.
Well.
Right. First of all, classifications of elements. First case is Lavoisier. One name is Lavoisier. Classification is based on what type of elements?
Valency.
Valency.
Monovalent type. Metals, non-metals, metalloids.
Not valence. Okay, no? Metals. What is meant by metals? Definition.
Metals are electropositive elements who will have physical characteristics like malleable, ductility, electropositivity.
Positive charge means
The
electron loses or gains.
Electron is easily lost, so that they will have positive charge in them.
The non-metals.
They are electronegative elements who will easily accept electrons, which are on the right.
Element present classified for this Lavoisier. Lavoisier periodic classification. How many elements is present?
No, I'm not aware. I guess it would be 96, 23 elements.
First of all, 23 elements is classified for metal or non-metals. Right. This Lavoisier drawback.
He was not able to arrange for metalloids.
Yes, that's true. Metalloids could not be arranged. Then insufficient of elements. Right. Then next one, Dobereiner-Dreitz rule. This Dobereiner-Dreitz rule, first atomic weight is similar to atomic weight and third atomic weight is average mean for second atomic weight. This is known as Dreitz rule. Dreitz rule, all elements could be arranged. Applicable, all elements?
No, there were certain elements which could not be arranged according to this rule.
Copper, silver and gold could be arranged with this rule.
I'm not aware of the atomic masses.
Copper, group number 11, copper, silver and copper, silver, gold. This group of 3 elements, this arranged with this Dobereiner explained.
No, he couldn't. That's why this table failed.
Reason, only for 18 elements is applicable. It could not be arranged in D and F block element.
Okay.
D and F block elements consider this group failure.
Okay.
Then Newton-Raphel law. Which element is applicable?
Up to nearly 40 elements. It was up to calcium. It was correct. After that, some elements were misplaced in his table without following his own rule, especially nickel, which was arranged along with the halogens. So there were some elements like which he could not answer. He misplaced it deliberately in halogen.
Only applicable for calcium up to 20 elements.
20.
Not insert for this inert gas elements, noble gas elements. Not discovered this neuron targets. Neuron targets நಮಗೆ அந்த கேஸ்ல நமக்கு inert gas elements கிடையாது.
It was not discovered.
இந்த சொல்ற கேஸ்ல lithium is the first element and is continuous for this 8th element for neon. Lithium is
It was not
most reactive or less reactive than lithium.
Sir?
Lithium which one is most reactive or less reactive than
More reactive. It has valence is 1.
Right, okay. Inert gas elements, neon is
Very inactive. Inert gases.
less reactive. These are the same cases for lithium is first, beryllium second, boron third, carbon fourth, nitrogen 5, oxygen 6, fluorine 7, neon is 8. What purpose of neuron targets law? First element, sari gamma balanisa. First letter sir, 8th letter sir. It is every first element is similar to every 8th element. It is the same chemical properties. It is known as neuron targets law. It is known as neuron targets law. But this case, lithium does not consider this inert gas elements. But lithium is same similar to sodium. Lithium is same similar to sodium. Any one of these nitrogen is first element is considered. It's every 8th element for oxygen second, fluorine third, sodium fourth, magnesium fifth, aluminum 6, silicon 7, phosphorus is 8. I mean, anyone lithium or any one element first considered, every 8th element is present in the same group of element. Same group of element is known as the same chemical properties. Same technical properties. This is explained for this neuron target law. Only applicable for 20 elements.
20.
Not to be arranged for these B block elements, inert gas element not discovered. Then Luther makeup. It is what based on the Luther makeup developed the theory.
Same atomic mass.
Atomic mass. Right. Atomic mass. Right. Atomic mass, atomic volume is like that. Electropositive element. Overall, the curve நம்ம curve keep பண்ணினா நம்ம அந்த கேஸஸ்ல நம்ம டிரா பண்றோம். இப்போ இந்த இதுல electropositive elements எந்த பிளேसेसல பிரசன்ட் ஆயிடும் அந்த கர்வ்ல. இப்போ நம்ம ஒரு T கர்வ் போட்டுட்டோம். அந்த கர்வ் வச்சு எக்ஸ்பிளைன் பண்றோம். இப்போ electropositive elements which position is present? Ascending or descending or bigger or bottom of the curve?
Oh, Lothermeier's graph is not in this book, which is given to me, and I only know NCERT book, NCERT CBSE book. I'm not much prepared with other books, and that particular graph is not in this book as well.
Actually, பாத்தீங்கன்னா இது ஃபவுண்டேஷன். அப்படிங்கும்போது நம்ம நீட் ஜேஇ கிளாसेसல கூட நம்ம இதுல அதை டெப்தா போனா மட்டும் தான் உங்களுக்கு அங்க வரும்போது ஈஸியா இருக்கும். ரைட், ஓகே. டாப் ஆஃப் தி பீக் அண்ட் தி கர்வ்ல தான் நமக்கு எலக்ட்ரோபாசிட்டிவ் எலமெண்ட்ஸ். ரைட், ஓகே. இப்போ இசடிஎஃப் எஃபெக்டிவ் நியூக்ளியர் சார்ஜ். எஃபெக்டிவ் நியூக்ளியர் சார்ஜ் வந்து உங்களுக்கு ஃபார்முலா தெரியுமா? எஃபெக்டிவ் நியூக்ளியர் சார்ஜ் இசடிஎஃப்.
No, sir.
What is mean by ionization energy?
Ionization energy is the energy which is required to attract the electrons of the other elements.
Attract or loses?
Both the cases, it will try to keep its withhold its electrons, and it will not allow its electrons to be attracted by the other one.
Actually, ionization energy, some amount of energy is needed to some electron is loses. The electron loses is known as ionization energy. Right? Okay. First of all, neon ionization energy is greater or lesser?
Lesser, because it will not lose very easily.
Why?
Because it has got its octet rule, complete fulfillment of electrons. Its valency is 0, so it will not react.
முதல்ல கான்செப்ட் நமக்கு ionization energyங்கிறது ஃபர்ஸ்ட் ஒரு அவுட்டர் மோஸ்ட் ஆர்பிட்ல உள்ள எலக்ட்ரான் ஒரு சம் அமௌண்ட் ஆஃப் எனர்ஜி கொடுத்து ஒரு எலக்ட்ரான் ரிமூவ் பண்ணும். அப்படி ரிமூவ் பண்றதுக்கு சம் அமௌண்ட் ஆஃப் எனர்ஜி நம்ம என்ன ப்ரொவைட் பண்ணுவோம். அந்த சம் அமௌண்ட் ஆஃப் எனர்ஜி இவன் ஸ்டேபிள் கான்ஃபிகரேஷன் ஃபார் தி நியான். அப்புறம் அவன் ஈஸியா கேன் பி ஈஸிலி ரிமூவ். அப்படிங்கும்போது அவனுக்கு சம் அமௌண்ட் ஆஃப் எனர்ஜி இஸ் நீடட் இஸ் மோர்.
Okay.
அப்ப ionization energy is greater.
More for neon. Okay.
It's a completely built on completely stable electronic configuration. Ionization energy is higher. Okay. But in the same cases, for first ionization energy, sodium. Sodium atomic number
11.
11. Electronic configuration. Right. The Abba principle for the electronic configuration, what is the
No, I'm not much used to that configuration because only 9th and 10th book. I'm not much practiced to that. Only from 9th and 10th book. 9th and 10th NCRT book alone. We don't write that configuration. We only do KLM shell configuration alone.
This case, 2, 8, 1. If a first orbit is coming for 2 electrons, second orbit is coming for 8 electrons, stable electronic configuration. But third orbit is coming for 18 electrons. 18 electrons or 8 electrons is coming after configuration. But this case, first initiation energy is easily loses, easy or larger or lesser. First initiation energy in this sodium
It is larger because it will very easily lose.
easily lose.
Yes.
Why? Our large initiation energy or small initiation?
Lesser energy.
Lesser initiation. Why?
Because it can easily lose its electrons.
Easily, one electron easily loses to stable electronic
Get
configuration. Right, okay. If I get a solid sodium solid metal, direct initiation energy convert பண்ண முடியுமா? Solid metal actually இப்ப நமக்கு ஒரு எலக்ட்ரான் ரிமூவ் பண்றோம். Sodium is metal or liquid?
Metal.
Metal. அந்த metal cases வந்து one electron can be easily removed.
Yes.
Sure.
Yes. One electron can be easily removed from
solid
sodium.
state is easily can be used.
Of course, yes, it is. If only if it loses this electron, it will get stable.
Solid cannot be used.
It has to be first ionized.
It convert to gaseous form. It convert to gaseous form. After solid to gaseous state, what process? Solid to gas.
Deposition.
Solid to gas, correct? Solid to gas. Change it to viscous state.
You have to heat it.
Condensation, vaporization of the solid to gas means? No.
Sublimation process, but not all the elements will sublime.
Sublimations. Okay. Sublimations. நம்ம solid metal gaseous state convert பண்ணி முடிச்சதுக்கு அப்புறம் தான் நம்ம என்ன செய்யணும்? அதுல இருந்து ions can be easily removed. So solid state remove பண்ணணும். Electron affinity any area?
It is the energy required by the nucleus to hold all the electrons.
Gain of electron, attraction of electrons. So it is an electron affinity. In this case, same gaseous state is gain of one electron gives negative charge distribution for electron affinity. First addition of electron. What type of energy is released? First
Activation.
electron, first addition of electron. One gaseous atom is added to one electron. Some Cl minus negative charge is produced. But this amount of heat energy, exothermic or endothermic?
When it accepts electron, endothermic, I guess. No, I'm not very sure, pretty sure, because I have been only trained in 9th and 10th NCRT book. Not much used for foundation or 11th, 12th book. I'm not aware of it.
Okay, thank you.
Thank you.